Quiz 1, Algebra 2, 5th period. Let's work through this quiz just to see if you have any kind of questions or problems that you need to resolve. Rewrite in exponential form. So this is y to the 5/7. That's how you go from radical to exponential form. Problem 2. This is the 9th root of z to the 5th. Or you can write it like this, the 9th root of z, all of that is raised to the 5th power. Either one of those is accurate for converting from exponential to radical form. Then I go through a series of problems where I'm asked to simplify radical expressions. Problem number 3, square roots. I cannot take the square root of 54, but can I simplify it? Divide that by 2 and you get a 27. Divide that by 3 and you get a 9. Divide by 3 and you get a 9. Excuse me, you get a 3. Because it's square roots, do I see anything happening 2 times? Yeah, so this is 3 squared times 6. So I can write this as the square root of 3 squared times 6. X to the 7th, I'm going to write that as x squared, x squared, x squared x. Y to the 4th, I'm going to write that as y squared, and then finally my z. Because it's square roots, what are all my perfect squares? So those are all my perfect squares. Those things will come outside the radical. Square root of 3 squared is 3. Square root of x squared is x. How many do I have? I've got 3 of those. The square root of y squared is y. I've got 2 of those. And all that's left inside the radical is 6xz. So that is in simplest form for that expression. Number 4, I've got radicals and I'm hoping to combine them with addition and subtraction. I can only do that if the radicals are identical. So can I simplify that? This is 3 times the square root of 2 times 25 minus 10 square root of 2 minus 2 square root of 2 times 16. In the first case, the square root of 25 is 5. So I'm going to have 5 times 3 square root of 2 minus 10 square root of 2. In the last case, the square root of 16 is 4. So minus 4 times 2 square root of 2. So I get 15 square root of 2 minus 10 square root of 2 minus 8 square root of 2. 15 minus 10 is 5. 5 minus 8 is negative 3. So negative 3 square root of 2 is my final answer. Number 5, 4th root of 162 minus the 4th root of 32. Well, I have to have these being like if I'm going to have any hope of combining them. So 162, I look at it and I can tell it's an even number. Divide it by 2 and you get 81. And then this starts to feel familiar. That's divisible by 3, divisible by 3 again, and divisible by 3 again. Because these are 4th roots, is there anything in this list 4 times? Yes, I see 4 3s. So this is the 4th root of 3 to the 4th times 2. And then when I look at 32, so 32, when I divide that by 2, I get 16. Divide by 2, I get 8. Divide by 2, I get 4. Divide by 2, I get 2. So I see 4 2s. So this is minus the 4th root of 2 to the 4th times 2. So in this case, 4th root of 3 to the 4th is 3. So 3 times the 4th root of 2 minus the 4th root of 2 to the 4th. So 2 times the 4th root of 2. Now I have the radicals alike, so I can say 3 minus 2 is 1. So this answer is just 1 times the 4th root of 2. And that's your final answer. Number 6, I am multiplying. So this is the 5th root of 2x times 16x to the fourth. So this is the fifth root of 32x to the fifth. The fifth root of 32 is 2 because 2 to the fifth is 32. The fifth root of x to the fifth is x. That is your answer, 2x. Number 7. Looks complicated, but it's just really about being organized. So if I've got quotients with exponents, this is going to be x2. If I look at the top, I've got an x squared minus negative 2. Y, I've got a negative 2 and then minus 4. Z, 4 minus negative 4. So this is x to the fourth, y to the negative 6, times z to the 8th. Making sure I leave no negative exponents, this is x to the fourth, z to the 8th over y to the 6th. Okay. Number 8, the key thing that I look at is this negative 3 exponent. I want to make that a positive exponent. So I can flip the numerator and the denominator. All of that is raised to the third power. Now I'm just going to simplify inside the parentheses. This is x to the 3 minus 1, y to the negative 1 minus 3 over 2. All of that is cubed. So this is x squared, y to the negative 4th over 2. All of that is cubed. And I'm going to continue down here. This is x squared over 2y to the 4th cubed. So when I cube all of that, I get x to the 6th over 8, y to the 12th is my final answer. Number 9, cube roots. Cube root of 24b to the 6th. This is the cube root of 8 times 3 b cubed, b cubed. My perfect cubes are 8, b cubed, and b cubed. So the answer is going to be cube root of 8 is 2. Cube root of b cubed is b, but I have 2 of those. So 2b squared times the cube root of 2 is the final answer there. Number 10, hopefully you got this one in a hurry. This expression right here in parentheses, raised to the 0 power, that's just 1. 2 times the square root of 1, which is 2 times 1, which is 2. Second page, evaluating numerical expressions with exponents. So negative 27 to the 2/3. This is the cube root of negative 27 squared. Cube root of negative 27, that's negative 3, because negative 3 times negative 3 times negative 3 is negative 27. So when I square that, I get 9. 1/4 to the negative 3/2. That's the same as 4 over 1 to the positive 3/2, which is 4 to the 3/2, which is the square root of 4 cubed. Square root of 4 is, cubed. So square root of 4 is 2, 2 cubed. This answer is 8. Number 13, cube root of 3 times the cube root of 9. That's equal to the cube root of 3 times 9. Now you can write this, that's the cube root of 27, which is 3. So that's one way of getting to your answer, or you could have said, this is the cube root of 3 times 3 squared, which is the cube root of 3 cubed, which is still 3. Either way, you get to the same answer. Number 14, negative 2 to the negative 2. Now keep in mind, this is not It's not that problem. That's a different problem. Okay, the only thing being raised to the negative 2 is 2, not negative 2 in our original problem. So this is the negative of 1/2 squared. So I move that 2 to the bottom and I change my exponent to positive. So this is negative 1/4. The problem over here that you did not have, this is negative 1/2 squared. This is 1/4. So there's a difference between those if you made that mistake. Down to the n, okay, 2 over root 3. How do I rationalize that? Well, that will be done by multiplying by the square root of 3 over the square root of 3. And I get 2 square root of 3 over square root of 3 times square root of 3, which is just 2 square root of 3 over 3. Number 16, 5th root of 2. So if I want to rationalize something that's the 5th root of 2, when I have 5th roots, I want to take the 5th root of something to the 5th. So I need to multiply by the 5th root of 2 to the 4th over 2 to the 4th. That will give me the 5th root of 2 to the 4th in the numerator. And on the bottom, I will get the 5th root of 2 to the 5th, which is what I wanted. So this is the 5th root of 16 over 2. And that is your rational form, rational denominator. Okay, this next one. If you get this one, you are really A+ on all your exponents. This one was complicated. So I've got 48 to the 1/4 times 48 to the 1/3 times 48 to the 1/2. That is 48. I add those exponents. 1/4 plus 1/3 plus 1/2. Common denominator is 12. So this is 48 to the 3/12 plus 4/12 plus 6/12. This is 48 to the 13/12. Okay, that is this answer right here. Okay, but you can tell from this problem the teacher's trying to trick you. Are any of these other expressions the same? Okay, well, if I look at 48 to the 13/12, how can I simplify that? So that is the 12th root of 48 to the 13th power. Well, that's the same thing as the 12th root of 48 to the 12th times 48. The 12th root of 48 to the 12th is 48. So this is 48 times the 12th root of 48. Well, lo and behold, that is answer C. So that's an identical expression. Then I got to look and see, well, what about A? Is the teacher still trying to trick me on this? Can I simplify the 12th root of 48? Because you look at it, what's the difference between A and C? Well, instead of the 12th root of 48, you got cube root of 2 times 12th root of 3. So let's look at this. 48 times the 12th root of 48. Well, this is 48 times the 12th root of 3 times 16. So this is 48 times the 12th root of 3 times 2 to the 4th. That is 48 times the 12th root of 3 times the 12th root of 2 to the 4th. Well, 12th root of 2 to the 4th. Let me just work on that right here. 12th root of 2 to the 4th, that's 2 to the 4/12. And that is the same as 2 to the 1/3. That's the same as the cube root of 2. So my final, this can be written as 48 times the cube root of 2 times the 12th root of 3. And lo and behold, that is A. So your answer is all of the above. Okay, that was really, really tricky. If you got that one, then you're A+ on all your exponents. Okay, that is the end of quiz 1. I wanted to work it out so you have it. If there are things you need to review before the unit test, which comes up on the 29th, you'll have this.